it's not destroyed, it's just flowing away or into the particle. But how exactly do we make energy flow out or into the particle? We look at how to change the kinetic energy. If you want to look at what will change the kinetic energy, you just look at what is the change of kinetic energy. Kinetic energy is 1/2 mv squared. Will 1/2 change? Will the mass of the particle change? So the only thing that will change is the speed of the particle. So you know it's just going to be 1/2 m times the change of the speed squared of the particle. So the change of velocity squared is final velocity squared minus initial velocity squared. That's what it means by the change of velocity squared, right? Now, final velocity has x component and y component. If you remember, velocity squared, which is speed squared, will be vx squared plus vy squared because it is the magnitude of that vector squared. You need to do Pythagoras theorem to sum the square of the components. So this term will have the difference in the x component squared plus the difference in the y component squared. I am just writing out all the things so I can tell you that this is the change of dx squared and this is the change of dy squared. If you are familiar with this, you can jump all the way from here to here because v squared is vx squared plus vy squared, so the change of it is just the sum of the change of individual component squared. Okay? Now, how do I change like vx squared? We first look at the easiest example when the external force is a constant. If you want to change velocity, you need to have acceleration. To have acceleration, you need to have force acting on the particle. So you need force to act on a particle to change its velocity. But how exactly do we change velocity squared? If the force acting on the particle is a constant, then the acceleration of the particle will also be a constant. And I hope from all the things you learned before your midterm, you know if the acceleration is a constant, then the x velocity of the particle will be changed by acceleration in terms of ax times t. The longer you accelerate an object, the more change you have in your x velocity. The x velocity will increase if you have positive acceleration, decrease if you have negative. Reverse sign if it is so negative that it becomes a negative x velocity. But that's how the velocity will change if you have constant acceleration. And for the displacement, the x displacement will be the area under the trapezoid. I hope you still remember that from your midterm. It's going to be as x bt plus 1/2 at squared don't need to memorize them. I will give it to you if this is going to be on the exam. So now, this is the formula we have if the acceleration is a constant. What we want is the change of Vx squared. Therefore, we want to get rid of t. There's no t in here. To get rid of t, we substitute t with Vx minus V0x divided by Ax. Is that too fast? Can you guys see why that is true? I need to do so. So let's move Vx and V naught x together, and then divide Ax to the other side. So we know we can look at how much the velocity has changed divided by acceleration and know how much time has passed. Okay? So it's very similar to getting the trajectory of a projectile motion. You substitute t with x and then get rid of t. You get a function of y in terms of x. And now I'm going to get a function of delta x in terms of the velocity change. Time is this guy, so I can replace it with the change of velocity divided by acceleration. If I have t squared, I just square it. I need to square the entire thing because the entire thing is what equals to the time. So this part is your first homework for today. So now, the first term will have V naught x times Vx, which will become V naught x times Vx. I hope that makes sense. V naught x times V naught x will be the square of V naught x. There's a minus sign because here's a minus sign. The whole thing is divided by Ax, so I need to divide it by Ax. That's the first step, okay? Now, for the second term, I have 1/2 times A times divided by A squared. There's a 2, there's A squared, and there's A in the denominator. So the denominator will end up being 2ax. Okay? There's 1/2, there's ax. This parenthesis square will give me a square. So a cancels a, and 2 times a is 2 times a. Okay? Now, the denominator is the square of two things subtracting each other. The binomial expansion is the first thing square minus 2 times the cross term plus the other thing square. You guys learned binomial expansion? Okay, good. Alright, so that's what we have. The first step of doing factor addition is to make the denominator the same. So I'm going to make the denominator becomes 2ax. In this case, I am multiplying 2 on both the numerator and denominator of the first term. That's legal because you can multiply the same number on numerator and denominator. In this case, I will have 2 Vx V naught x dx minus 2 V naught x squared. And for this term, the denominator is already 2ax, so I don't need to do anything. I just copy the denominator. My b is not b. Okay, so that's the thing. And now it's the fun part. We get to cancel stuff. We see V naught x times Vx, V naught x times Vx over here, Vx times V naught x. You can swap the order of multiplication. So these two terms is the same. You can see the 2 is the same. And 1 is plus, 1 is minus. So they cancel. Okay? And here, I have a V naught x squared and 2 V naught x squared. What is 1 minus 2? Good, so I will get a negative 1 V naught x squared. So I can say this cancels this, so it's negative 1. So this term is just Vx squared. And I get something I want. This is the change of x plus t squared, which is the change or a part of the change of kinetic energy. So this is what I want. Okay? So all you need to do is to start with the two equations, the velocity and displacement for constant acceleration. Substitute time with velocity change, follow the algebra, and you get a result. If you've done it once, then you should be able to do it in your exam, so don't worry. Now, I want the change of x velocity squared, and that is denominator here. So the change of x velocity squared divided by 2a